Schlumberger is proud to announce the launch of Dielectric scanner service, employing pioneering multi-frequency dielectric dispersion science. This video explains the measurement principles and then looks at applications of the technology that have helped customers with formation evaluation challenges, including carbonates, shaly sands, and heavy oil reservoirs. The heart of Dielectric scanner service is its short multi-spacing antenna array pad. Each of the cross-dipole antennas on the pad has co-located magnetic dipoles. The transmitters are in the center, and the receivers are placed symmetrically around them for optimal measurement accuracy and borehole compensation. To minimize environmental effects, the short, fully articulated antenna pad is applied firmly against the borehole wall by a hydraulically operated eccentric caliper to optimize pad contact, even in rugose boreholes. Electromagnetic waves are propagated into the formation at 4 frequencies and 2 polarizations to provide high-resolution, high-accuracy measurements of reservoir properties at 1-inch vertical resolution close to the borehole wall. As the electromagnetic waves travel from the transmitter to the receiver, changes occur in amplitude and phase. These changes are directly related to the dielectric permittivity and conductivity of the formation. Because of the large contrast between the permittivity of water and that of oil and of rock, the tool makes a direct measurement of the water volume that is independent of salinity. Depending on the texture of the rock, the dielectric permittivity and conductivity change with the frequency of the electromagnetic waves. This phenomenon is known as dielectric dispersion. In carbonate reservoirs, dielectric dispersion is related to the cementation and saturation factors. In shaly sands, it is related to the shale volume or cation exchange capacity. Obtaining textural information and accurate water volume measurements is possible only with multi-frequency dispersion data, and the dielectric scanner is the only multi-frequency tool in the industry. The Archie equation is the simplest saturation equation relating rock properties to saturation. The saturation exponent and cementation factor are related to rock texture. Errors introduced in these parameters have a significant effect on the accuracy of the computed saturation. Determining these parameters from core measurements is both time-consuming and expensive, and provides data only at discrete depth points. Dielectric scanner multi-frequency dispersion measurements provide accurate saturation equation parameters as a continuous output. Low salinity formation water makes it difficult, if not impossible, to identify oil zones with conventional triple combo logs. In this example from the Kern River field, the water saturation curve computed from resistivity is incorrect. Comparing the dielectric scanner salinity-independent water volume with the total porosity not only identifies the oil zones, but also enables accurate quantification of the hydrocarbon saturation. The dielectric scanner saturation values were verified several weeks later by running RST carbon-oxygen measurements made in a cased hole environment after the well was completed. With multi-frequency dielectric dispersion science from Dielectric scanner service, the accuracy of formation evaluation is no longer dependent on estimated parameters or expensive, time-consuming core analysis.